Okay, 1A, let's take a look at that. My first term has 1 box. My second term has 3. My third term, let's count them up. 1, 2, 3, 4, 5, 6. My fourth term has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we want to figure out what is going on and what is the next terms. So when I look at this from 1 to 3 to 6 to 10, what I notice is in between there, I keep increasing by 1. So it should be a plus 5 to make for the fifth term. Should be what, 15 boxes. And then for the next term, plus 5, so plus 6. 15 plus 6 is 21 boxes. I am not going to attempt to draw that out. All right, number 2 we did in I did in class. So I'm going to do number 3B. All right, on 3B, we want to figure out if it's arithmetic or geometric, state the difference of the ratio, and then figure out the next two terms. 5 to 10 to 20 to 40, make sure it works for everything, and multiplying by 2 does that for me. So it's a geometric, since we're multiplying, sequence. If it's a geometric sequence, we have a common ratio, which in this case is 2, multiplying by 2. Therefore, 40 times 2, and then 80 times 2. And there's my next two terms, okay? Letter C, negative 4.8 to negative 6, negative 6 to negative 7.2. Okay, well, it looks like I'm decreasing. I'm going down, so I'm going down there. In this case, subtract it. 6 minus 4.8, that's going to give you a difference of 1.2. Keep subtracting 1.2. Keep subtracting 1.2. So 1.2 minus 1.2 is what's happening here. So we're adding a negative 1.2. Since we're adding a negative 1.2, that means it's an arithmetic sequence, and therefore it's called a common difference. And that common difference is negative 1.2. Now, keep going. Negative 8.4 plus negative 1.2 is negative 9.6. And negative 9.6 plus negative 1.2 is negative 10.8. Letter F. 12 to 16 and a half to 21 to 25 and a half. Okay, that's not multiplying, doesn't seem to be anything obvious there. So let's try to figure out something that adding on to that. 12 to 16 is 4 plus a half, so 4.5. What's 16.5 plus 4.5? Does it check out to be 21? And it does. 21 plus 4.5, does that give you 25.5? It does. So what that means is we are adding 4.5. And since we are adding, that means it's an arithmetic sequence, and therefore we have a common difference. So then 25.5 plus that. So 25.5 plus 4.5 gives me 30. And then 30 plus another 4.5, that's that recursive formula. Just keep adding 4.5. All right, 4A. Here, we want to find the 11th term. So we're going to plug in that. 11 for n, and then do order of operations. And then you go to your calculator, and let's type in 3 times 4 to the 10th power. Type it in exactly as you see that. And we get 3,145,728. So 3,145,728. Letter C, the 25th term. So we're plugging in as 25 to find that. So what we want to do then is our order of operations. 25 minus 1 is 24. So 3 minus 5 times 24. Plug in exactly as you see that. And the 25th term turns out to be negative 117. Now letter D turns out to be not stellar to work with because of that fraction of going to the 10th power. So the answer on that one, let me just set it up for you. It's just not an easy one to necessarily work out because of this fraction and doing this one. This is basically where we want to get to, if you could realize all this right here. And then you would plug it into your calculator. But this one is hard to do because of fractions, and our calculator can only do so much. So long story short, what the answer should be is this right here. 1 over 19,683. If you can do this, you're going to be fine. And if you can do the ones up above, you should be fine too. Okay. 5C. Got to write an explicit formula to help us figure out what's going on here. And I'm not going out 28 terms to find it. So I want to write an explicit formula. First thing I have to figure out is, are we adding or multiplying to go from here? And I can do 3.3, 4.4, 5.5. So what's happening? To go from one term to the next, I am adding 1.1. So since I'm adding, that is code for arithmetic. And if you're arithmetic, you're going to have a common difference, which in this case is 1.1. Now, what we've been talking about is for an arithmetic sequence, the explicit formula looks like this. So you need to know what the first term is, which in this case, the first term is 3.3. You need to know what the common difference is, which we just found. So all that stuff we just created right there by looking at what's the first term of the sequence and then what was the common difference. Now we can find anything we want. And in this case, we want to find the 28th term. So when I plug that in, it's just like what we've been doing. We're going to do 3.3 plus 1.1 times 27. And the 20th term turns out to be have a value of 33. On letter D, same thing's happening. Here, we are going from 135, we dropped really quick down to 45, 45 to 15. For myself, the quick one that sees from 45 to 15, divide by 3. Now, dividing by 3 is fine, but it's not stellar. We want to say divide by 3 is the same thing as multiplying by its reciprocal by a third. And because it's multiplication, we get a geometric sequence with a common ratio, which in this case is a third. Now, the explicit formula for a geometric sequence, remember, looks like this. The first term of this series, of the sequence, times the common ratio to the n minus 1, which in this particular problem, what is the first term? 135. And what's my common ratio? That is that 1/3. So that's going to work for this specific sequence. Now I want to find the 7th term. So I'm going to plug in to my calculator this right here, 135, as I clean that up a bit, times 1/3 to the 6. So when you go to your calculator, type it in exactly as we have it, okay? You get not a stellar fraction here, sorry, stellar decimal. So when I do that, you get 5 over 27. Now how I'm getting that, I'm going to show you now on my graphic calculator that you guys have access to. So let it come up on my screen here. Okay. I typed in 135 times 1/3. This is all old stuff. This is nothing new. To the 6th power. And as I said, I got this decimal. I don't want to give that decimal. So the way I can do this is tell my calculator to change that decimal back to a fraction. Sometimes your calculator can do it, sometimes it can't. Sometimes it's just too nasty. So if I hit math and then option 1, that changes every decimal to a fraction, which in this case is how I'm getting that 5/27. So as you work through things, learning how to use the calculator is the other big part of that. Last one, number 6. Okay, if you get a curve on number 6 here, like I do on letter A, that is going to be then a geometric sequence. Curves are geometric, like I have here. If they are making lines, like letter B and letter C are doing, that is an arithmetic. Now, the last one there, okay, is not a curve, but what I notice, and this is one of the geometric graphs we've looked at before, it kind of goes negative, positive, negative, positive, negative, positive, negative, positive, negative, positive. As it alternates like that, what this is actually an example of is a geometric sequence. And what's happening with that, when we've looked at this before in our notes, it is very similar to what we would have done here on this example, where you go from positive to negative, positive to negative, positive to negative. You're multiplying by a common ratio of -2. Because that's happening, that's where you're getting this graph to occur, like on letter D. So that's a geometric sequence.